Welcome to the Explainer. Today, we're diving into something that is literally going to rewire how we think about artificial intelligence over the next decade. Look, when you hear the name Qualcomm, you probably think of that little chip heating up inside your smartphone right now, right? But they are making a massive, multi-billion-dollar pivot straight into the heart of AI data centers. We're going to unpack their strategy, and then we'll look at a really fascinating prophecy for where this whole technology landscape is heading by the year 2035. So, this question right here, this is the entire premise of our explainer today. Up until now, the AI boom has mostly been defined by training. That means feeding massive amounts of data into massive supercomputers to create models like ChatGPT. But running those models out in the real world for billions of users, that's called inference. And running AI is a completely different game than training it. It requires an entirely different approach to hardware. Okay, let's dive into this. Here is our roadmap for today. The AI data center pivot, the Dragonfly Arsenal, Qualcomm versus NVIDIA, the 2030 hardware evolution, and finally, that 2035 Inference Vision. Section 1, the AI data center pivots. Let's start with the immediate future, because this is not just some side project for Qualcomm. It's a full-scale assault on a brand new market. By 2026, Qualcomm will officially launch Dragonfly, and this is their new brand dedicated entirely to AI data centers. For a company known, up to 2025 primarily as a smartphone maker, this is a monumental shift. They're moving way beyond their mobile legacy to build the actual infrastructure that will serve AI to the rest of the world. Section 2, the Dragonfly Arsenal. So what exactly are they building? Well, our sources outline 5 core pillars to their strategy, which proves they aren't just making a single chip, but a whole ecosystem. Now, what's really interesting about this slide is the sheer speed of this rollout for their primary AI inference accelerator. Check this out. In 2026, we get the AI 200, which is built strictly for large language model inference. The very next year, the AI 250 introduces their first generation of high bandwidth compute. And then by 2028, the AI 300 brings Generation 2. They are iterating at breakneck speed here. And they are packing these accelerators with some serious hardware, 768. That is the massive number of gigabytes of LPDDR memory in that upcoming AI 200. Just to put that into perspective, the laptop you're probably using right now, it might have 8 or 16 gigs. So why does this massive capacity matter? Well, running large language models requires holding vast amounts of data in memory all at once. By using low-power DDR memory, the kind you usually find in mobile devices, they're optimizing for huge capacity while keeping the power consumption incredibly low. And that brings us to their third pillar, which is a massive structural breakthrough called High Bandwidth Compute, or HBC. Traditionally, graphics processing units sit next to extremely fast but very expensive and very power-hungry high bandwidth memory, or HBM. But Qualcomm is completely reinventing this specifically for inference. They're actually 3D stocking lower-cost, lower-power LPDDR memory directly underneath the compute die. It's an architecture designed purely for efficiency. To finish out this arsenal, they're providing everything else a data center needs. They're introducing the C1000 server CPU to act as an AI orchestrator. They're building optical DSPs for literal lightspeed connectivity between chips. They're offering custom silicon design for mega corporations like Meta or Microsoft. And they're backing the whole thing up with open software compatibility like PyTorch and VLLM. They want to sell you the entire AI rack, not just one isolated piece of hardware. Section 3, Qualcomm versus NVIDIA's strategy. Now, it's absolutely crucial to look at this impartially, because this isn't some direct cage match. It's really a clash of 2 entirely different architectural philosophies. And this brilliantly illustrates that. NVIDIA dominates by doing both training and inference, using incredibly powerful multipurpose GPUs paired with expensive HBM memory and their proprietary CUDA software. But Qualcomm? They are taking a completely different lane. They're ignoring training entirely. They are building custom inference specialized chips with their HPC memory architecture, relying on open software. They aren't trying to build the machine that creates the AI. They want to build the machine that runs it for the absolute lowest possible cost. So the underlying design philosophy here is tokens per watt and an inference-first mindset. When you're serving AI to a billion people every single day, absolute peak performance isn't actually your biggest bottleneck. Your electricity bill and your total cost of ownership are. And that is exactly the problem Qualcomm is aggressively targeting. Section 4, the 2030 hardware evolution. So, based on public data and industry trajectories, our source lays out this predicted roadmap for the physical evolution of data centers. And this timeline charts a fascinating progression. We start in 2026 with dedicated LLM inference chips. By 2028, we scale up to full rack AI orchestration. Then, 2030 brings a massive shift toward persistent memory AI. By 2032, traditional racks start to blur into AI factories. And finally, by 2035, the source predicts a unified planet-scale AI fabric. Let's look a little closer at these milestones. Heading into 2029, the prediction for the AI 400 generation shows a really radical architectural shift. We move away from massive single-piece silicon chips into multiple chiplets joined together. But even more importantly, the high-bandwidth compute architecture evolves to fuse memory and storage compute together. This means the AI accelerator will actually be able to read data directly from SSD storage, totally bypassing the CPU. The traditional bottlenecks are just being systematically eliminated. Now, this hardware evolution is completely necessary because of what happens in 2030, the shift to memory AI. Right now, you ask an AI a question, it answers, and it essentially forgets you exist. But by 2030, imagine an AI agent retaining months of conversational memory for deep reasoning and long-term planning. That is going to require an unimaginable amount of memory capacity. And this perfectly explains why Qualcomm's bet on high-capacity, low-power LPDDR memory today is a strategic masterstroke for the AI agents of tomorrow. And to connect all this massive memory and compute, the physical cables themselves have to change. We're stepping away from traditional copper wiring, which is just way too slow and runs too hot, moving to pluggable optical cables using light to transfer data. But the prediction is that by 2030, we will actually achieve chip-to-chip optical connections. Think about that. The traditional green PCB motherboard will essentially disappear, replaced entirely by photonics, literally light transferring data directly between silicon chips. Section 5, the 2035 Inference Vision. So what does the data center actually look like in 2035 when all of these predicted advancements fully mature? Well, by 2032, the very concept of a server rack begins to dissolve. You aren't going to have a box for computing and a separate box for storage anymore, because everything is communicating at the speed of light via that chip-to-chip optical connection. The entire data center becomes one massive, unified optical mesh. It acts as a single computing organism. Let's move to the ultimate 2035 endgame and see how this builds. This is where the source predicts Qualcomm evolves into a pure inference computer company. Just look at how this stack operates. It's a seamless sandwich going from top-level photonic fabrics, down through agent CPUs, into a unified memory fabric, and finally down to dedicated inference tiles. In this future architecture, the traditional idea of a standalone GPU becomes completely ambiguous. The hardware boundaries have dissolved entirely to serve one single purpose: running world-scale AI as efficiently as possible. Which leaves us with this final, overarching thought for today. Right now, all the glory goes to the massive supercomputers training the next generation of AI. But as AI becomes as ubiquitous as electricity, the true infrastructure battle might not be about creation, but about delivery. So will the future of AI ultimately be defined by who trains the models or the companies that build a fabric to run them? It's definitely something to think about as this landscape shifts right under our feet. Thank you so much for joining me for this explainer.